So here we have a SITRANS LT500 fresh out of the box, and I'm going to do a quick start on a flow application. So measurement point 1, we're going to do volume flow, and we're going to stick with most of the defaults here just to do a quick little setup. We'll go to a fast response rate. And we'll use a rectangular flume, absolute. Approach width, let's say, is 1 meter. Throat width is 0.5 meter. Hump height is 0.1 of a meter. And throat length is 1 meter. Max head, 0 head offset, and low flow cutoff we can leave at the defaults, and we can apply that. Now on point 2, let's just do a basic level application. So meters as well, and yes, I've got an LU240 connected there. And let's just do a quick level setup so that we have some more values to show in our log. So now we've done our setup, and our device is now calculating flow. So I'm going to go through to my memory card setup, and I'm going to go to Datalogging, and instantaneous value versus an average value is looking at your logging frequency and whether or not you want to take the value when the log is being saved, or if you want to take the average of that value over the duration of the frequency. So for us, we'll stick with the instantaneous value. The logging interval is how often the log will be done. So we can see we have 5, 10, lots of different options for logging intervals, all the way up to 1 day. 24 hours, even in the milliseconds, if we really want to get critical. 5 seconds will be good enough for our demonstration. And the process values. So on the first PV, let's do volume flow. Our second value, let's do distance on point 1. Our third logging value, let's do sensor temperature on point 1. And our fourth value, let's do the totalizer on our point 1. We can do up to 9 different logged values, specifically the PVs. And for logging value 5, let's go to level point 2 and temperature for point 2. For 7, let's do distance on point 2. And that should be enough. We still have 2 more values that we could log, but I think that'll show everything we need to for the purposes of this demonstration. Advanced logging is a menu that will only appear if you are unlocked in expert mode. And advanced logging allows you to log any parameter that the device has a Modbus register for, which is all of them. So we can see here that we have all of our different options selected for the different logging registers, but in 8 and 9, we don't have anything. So we can insert any parameter value we want here. So for example, in register 8, I'm going to put in the level point 1 status, which is Modbus register 3487. And in register 9, I'm going to put the status of measurement point 2, which is Modbus register 3488. And all the Modbus registers can be found online in the Modbus map. So now I am logging 7 different PVs and 2 different parameters. And like I said, you can log up to 90 different items. So 90 different parameters can be logged. What do we want to do with the behavior at full memory? We can either fill and stop or first in, first out. Fill and stop should work for almost any application. We can literally do hundreds of years if we're logging at like a 2-minute interval. Even with 9 PVs, it'll last quite a long time. So not a huge concern. The diagnostics, we have the defaults on, so when we have 7 days remaining of logging, we can raise a flag. When the memory is full, we can raise a flag, and those can be attached to relays as well if need be. For your log file, sometimes Excel in different regions uses a comma instead of a decimal point. So that option is in here as well for ease of use. And then finally, we come to enable our data logging. So as soon as data logging is enabled, you'll find that the other parameters are not accessible because if we change the log, we can't do that in the middle of logging. So anytime change is required, you'll need to disable the log and then re-enable it again. So we'll go ahead and we'll start our log, and we can see when we go back out to our display view that in the bottom right hand corner a little memory card icon is displayed, showing that we are in fact now logging data on the device. And we can see that our totalizer is running. Point 2 we're also measuring, so we're logging all the information that we just input. Okay, so we have our data log from our LT500, and I'm just going to plug in the USB cable, which connects the device, and it shows up as a USB drive. And in my LT500, I see I have a data log file. And if I open that up, I can see that I have multiple log files, and they are all date stamped, so the year, the month, and the day. And if you see multiple files, all that means is that the log has been interrupted or stopped. So the first file was the one I just tested and checked to make sure it's working. The second one is the one that I've just left for about an hour to run. So I'm going to open up that file, and there's the text log. And you can see I've got my volume flow, distance, all my different values, but it's not terribly easy to read. So we're going to go into Excel and open up the exact same file and sort it, which will make it a little more easier for us to take a look at. So if I go to the Data tab and import from a text file or a CSV file, I'm going to open up directly off my micro memory card on the LT500, which is still connected here. Same thing, the data log file and the log file, which you'll notice doesn't come up right away. We need to select all files, and there we have the file we want. So you're going to get a dialog box that asks you how to separate the data. And for our use, we're going to have a semicolon, and you can see it's going to be a nice and neat separation. So we're going to load that up, and we can see what our log file looks like. So our volume flow, distance, sensor, temperature, and totalizer for point 1, and our level and temperature and distance for point 2. And then we have our 2 Modbus registers that we did on point 8 and 9 for our data log, which are the status of our sensors, which a number 3, if you look at the Modbus map, both means they were in a good state. So there's all of our information, and we can see the units come through, what the Modbus register is for that particular PV, and the units, and then all of our data. And so from there, we're able to chart that data. We can do some graphs. We can analyze what's going on, and we can potentially troubleshoot or diagnose the problem. So there you go. Nice, quick, and easy way to get your data logs off of the LT500.
Siemens. Ingenuity for life.